Welcome to Sorting Algorithms. In this lecture, we'll be first off understanding what sorting algorithms are. Then we're going to be looking at some examples of sorting algorithms. And the examples of sorting algorithms we'll be looking at today are selection sort, insertion sort, and merge sort. So let's first off start off by understanding exactly what a sorting algorithm is. And before we can even understand what a sorting algorithm is, we have to understand what an algorithm is. So an algorithm is a process or set of rules to be followed in calculations or other problem-solving operations. So anything like a set of directions or instructions or any process that occurs in order to make some calculations or any other operations is known as an algorithm. And what we're doing with sorting algorithms is, as you can probably tell by a name, with sorting algorithms, the purpose of sorting algorithms is to order a list in ascending order. So basically, we could have a list of numbers like 1, 5, 7, 2, and a lot of numbers. And the purpose of a sorting algorithm would be to order this list of numbers into ascending order. And by ascending order, I mean increasing order. So 1, 2, 3, 4, and so on. So the value should be increasing, and that's the order it should be in. So basically, now what we're going to do is we're going to look at a couple of different processes or set of rules or instructions that we can follow in order to order a list in ascending order. So the first example or first sorting algorithm we're going to take a look at is the search and swap. The selection sort algorithm, and it's also known as the search and swap algorithm because what it does is it takes an array or a list, an array or a list, and inside of it, it finds the smallest element. Now, whatever the smallest element is, it switched the smallest element with the first element. So now, whatever the first element is, it's the smallest element in the array or the list. And then what it does is it finds the smallest element in the subarray. And why I say subarray is because once the first element is already the smallest element, the algorithm automatically ignores the first element and continues on looking at all the other elements and finding the smallest element in those. And then it repeats this process until there's only 2 elements left. And when there's 2 elements left, it compares the two and determines which one is bigger and which one is smaller. So which one should be second to last and which one should be last. So now let's take a look at a graphic which can help us understand exactly how selection sort would work with a small set of numbers. So let's say that we start off with a list or an array of numbers, and these numbers are 3, 9, 6, 1, and 2. So what we want to do with this list of numbers is we want to order it in ascending order. So what happens now, as I mentioned, the first step is that this algorithm looks for the smallest element in this list. So we have 3, 9, 6, 1, and 2. And the smallest element in this list is 1. Now, because 1 is the smallest element, 1 automatically switches places with the first element in this array or this list. And the first element or this list is 3. So 1 and 3 automatically have their spot switched. And now looking at the second row, the new updated version of this list is 1, 9, 6, 3, and 2. And everything is still jumbled up except the first element is the smallest element. And that's exactly what we want. Now that the computer knows that the first element is most definitely the smallest element in this list, it's going to start ignoring the first element because it knows that this first element, 1, is already in the place it needs to be, and there's nothing the computer can do to it. So now what the computer is going to do is, after it ignores 1, it's going to look at 9, 6, 3, and 2. And within this subarray or sublist, it's going to look for the smallest number. And the smallest number in this sublist is 2. And we know that the first element in this subarray is 9. So now it's going to switch the spots of 9 and 2. So now the updated list looks like 1, 2, 6, 3, 9. So now, the computer knows that the first and second elements are exactly where they should be. 1 and 2 are exactly where they should be. So now, the computer will stop paying attention to those 2 numbers, and now it's going to look at even a smaller list because the 2 numbers have already been sorted into appropriate positions. And now it's going to take a look at 6, 3, and 9. And now it's going to try to find the smallest number in this small list. and the smallest number is 3. And the first element in this sublist is 6. So 3 and 6 will exchange places. And now the updated list looks like 1, 2, 3, 6, and 9. Now, you may think that it's done right now, but according to the computer, 1, 2, and 3, or according to the algorithm, 1, 2, and 3 are the only elements that are in the appropriate place. Everything else is not in place. And because the computer is not sure whether everything is in place, the computer or the algorithm will continue functioning until it's 100% sure. So we may know that 1, 2, 3, 6, and 9 are completely fine and that's the solution. But as far as the computer goes, 1, 2, 3 are completely right and 6 and 9 may or may not be right. So now because we have 2 elements left, the computer looks at 6 and the computer looks at 9. Now the computer says and determines the relationship between the two. So it knows that 6 is the smaller number of the two. So then 6 becomes the second to last number, and the bigger number of the two, 9, becomes the larger number. So as we look at selection sort, we see that constantly the algorithm is looking for the smallest number in a list, and after it finds that smallest number, it replaces that smallest number with the first element, and the smallest number is automatically moved to the beginning of the list or the sublist. And it continues to do that until it is sure that every single element is in its appropriate position. So the next type of the next sorting algorithm we're going to be taking a look at is insertion sort. And insertion sort is very similar to selection sort in many ways, but it's also very different. And now we have a nice graphic here that'll help us understand visually exactly how insertion sort works. So let's take a look at this. We have a different data set this time. We have 5, 2, 4, 6, 1, and 3. So now let's work through this using the insertion sort algorithm, and let's see what we get out. So what the insertion sort algorithm does is, what it starts by doing is, this red line, the red line that you see in every row, the red line to the left of the red line is everything that has been sorted, and to the right of the red line is everything that is yet to be sorted. So it takes the first element and assumes it to be part of the sorted list. So now it's saying that the first element is sorted, and that's completely fine. And then 2, 4, 6, 1, and 3 are yet to be sorted. So 5 is sorted, and 2, 4, 6, 1, and 3 are yet to be sorted. Now, after it has that set up, it looks to the right of the red line, or basically everything that is unsorted, and it looks at the first element in that list, and that first element is 2, because 5 is already sorted, but 2 is the first element that needs to be sorted. So then it compares 2 and 5 and determines exactly where 2 fits in. And as we know, 2 is smaller than 5, so 2 fits in before 5. So now what happens is the computer automatically moves 2 to the left of 5. So now the updated list looks like 2, 5, 4, 6, 1, 3. Now that the computer looks like this, we know that the red line now has 2 numbers to the left, 2 and 5, because 2 and 5 have now been sorted. And it has 4 numbers to the right, 4, 6, 1, and 3, and these numbers are yet to be sorted. So now it looks at the first element in the unsorted list, which is 4. And it's decided that it's going to move 4 to the sorted side. And now it just has to determine where does 4 fit in. And as we know, 4 fits in between 2 and 5. So now that the computer has figured out it fits in between 2 and 5, the computer automatically moves 4 in between 2 and 5. So now the updated list looks like 2, 4, 5, 6, 1, 3. 2, 4, 5 have already been sorted, and 6, 1, 3 are yet to be sorted. So now the computer looks at the first element of the unsorted list, which is 6, and it's decided that it's going to add it to the sorted side. So now the computer is unsure where to place it. So the computer looks at the existing sorted list and finds that the element it's trying to place, the number 6, fits in after 5. So then the computer inserts 6 after 5 into the sorted list. So now the updated version of this list looks like 2, 4, 5, 6, 1, 3, with 2, 4, 5, 6 being already sorted and 1, 3 yet to be sorted. So after this, what it does is it says, okay, so the next element that needs to be sorted is 1. and it looks at the sorted side, and it looks to see where this element that needs to be sorted, the number 1, fits in. And it sees that the element number 1 fits in right before the 2. So then what the computer does is it moves 1 to the position right before the 2. So now the updated list looks like 1, 2, 4, 5, 6, 3. And 1, 2, 4, 5, and 6 have already been sorted, and 3 is yet to be sorted. So now what the computer does is it looks at 3, which is the first element, and in this case the only element in the unsorted list, and it says, okay, I'm gonna move this element over to the sorted side, and it says let me insert it wherever it fits in. And we know, and the computer figures out that this element 3 should be inserted between 2 and 4. So the computer takes the element 3 and moves it over in between 2 and 4. And now what we have, the updated list looks like 1, 2, 3, 4, 5, and 6. And now the computer knows that all of the elements have been sorted because there's no more elements remaining in the unsorted list. And that's how the computer finishes. And as we know as well, the list is sorted in ascending order, so everything works out. So all we saw with insertion sort is that the computer keeps looking at one element at a time and moving it into a sorted list and placing it wherever it needs to be. So again, to recap, what happens is when it starts, it assumes that the first element is the sorted and the rest are unsorted. And after that, it looks at the first element in the unsorted list and it moves it over to the sorted list, and it keeps structuring it that way and keeps iterating that way until everything has been removed from the unsorted list and everything is sorted in ascending order in the sorted list. So now the best case that could occur for this insertion sort algorithm, and by best case I mean where the computer or anything with the least amount of time would be required, least amount of effort, is if everything was already sorted. And the worst case would occur if the existing list that needed to be sorted was in reverse order, so it was in descending order. And now we've looked at two sorting algorithms, insertion and selection sort, and they're really great and they're really simple logic, but they are inefficient for big lists because they require a lot of movement of the elements. That's why they're a little bit inefficient. So now we're going to look at a solution which is a lot more efficient for bigger lists. And the solution we're going to be taking a look at is merge sort. Merge sort is a sorting algorithm that is recursive, and basically what it does is, its function basically of merge sort is it splits the array in half. So whatever the existing array is, it splits it in half and it keeps splitting it in half until the array or the list is separated into individual elements. And then what it happens is it one by one merges two arrays together to create sorted arrays. And the disadvantage of this merge sort is that it creates a temporary array which can cause some memory problems. But let's take a look at an example so you can actually understand exactly what happens when you use merge sort. So here's the graphic we're going to take a look at for merge sort. So if you'll direct your attention to the left side under the split where we have four numbers, 13, 4, 1, 7. And these are all individual elements or individual parts of a list or an array. And what we're going to see exactly what merge sort does. So as we know, what merge sort starts off by doing is it starts off by splitting the array in half. And when it splits the array in half, 13 and 4 form one half, and 1 and 7 form the other half. And then it keeps doing this until we have individual elements left. Individual elements as arrays left. And what it keeps doing is now it's going to keep splitting these half arrays until there's one element, all elements have basically been separated. So it'll split the 13, 4 half array, and it's going to split that into 13 and 4. It's going to split 1 and 7 into 1 and 7, or the 1, 7 array into 1 and 7. So it'll keep doing this. In this case, we only had 4 numbers, so a lot of splitting was not required. But no matter how many numbers there are, it'll keep doing that until everything has been successfully split. Now that everything has been split, we have 4 elements that are split from each other, 13, 4, 1, and 7. And now, as you may know, they are not in order. So now what happens is, if you can direct your attention to the right side under merge and go to the bottom of this entire graphic where we have 13, 4, 1, and 7, and then we have some upward arrows. And what we can see here is after everything has been successfully split, then the merge sort algorithm starts to do what its name indicates. It starts merging these arrays together in a sorted fashion. So it's going to merge two separate arrays, 13 and 4. These are two separate arrays. It's going to merge these two arrays together so that the order is 4 and 13, because that's the correct ascending order. And now there's one array, which is 4, 13. And similarly, it's going to merge the two arrays, one with 1 and the other with 7. And it's going to merge these two together to create one array, which is 1, 7, because that's the correct order. Now it has two arrays, and it's going to merge these two arrays together. So it's going to merge the 4, 13 array with the 1, 7 array. And when it merges these two together, it automatically puts them in ascending order. And by putting 4, 13 and 1, 7 in ascending order, we get 1, 4, 7, 13. And that's exactly what the correct solution is. So basically what we can see from this merge sort algorithm is that what this does is it first splits everything and then it merges it together. So kind of splits everything into individual pieces, and then after that it combines those pieces in ascending order so the solution comes out to be correct. And it's recursive because what it does is it keeps splitting everything in half until it reaches its base case of each array containing only one element, and that's what it gets. And once it gets that, it goes to the merge process where it starts combining these arrays together in order to create a ascending array. And now what we've seen is we've looked at 3 different examples of sorting algorithms using different tactics, where we've seen how we can successfully sort a list of numbers so that they're in ascending order. And these sorting algorithms are entirely logic based. Everything was thought out through logic, and they're some of the most important algorithms in computer science.